Bismillahirrahmanirrahim. Today is our lecture number 21, chapter 2, differentiation, and the topic of today's lecture is derivative of exponential function. And some related question from exercise 2.6 we will also solve in today's lecture. So now I will start the lecture. You can see this. Here we have the derivative of a general exponential function. This is the topic of your book at page number 80. You can kindly open your books and see the topic. Here we have a function, a general exponential function. General exponential function is a function which can be defined as f of x is equals to a of x, where a is greater than 0 but not equals to 1. And in general, the exponential function, if we find the derivative of this general exponential function, so I will start it here. General exponential function, general exponential function. In general exponential function, here we have y is equals to a power x. This is the general exponential function in which a is greater than 0 but not equals to 1. We find the derivative. If we find the derivative of this function, we have two methods. First method is ab initio method, and or we call it first principle method and so on. The second method is the formula method, in which we apply different formulas directly. Formula method, in which we apply different formulas and find the derivative of any function. Now the first method, in which is the first principle method or ab initio method, in this type of method, I have told you in my previous 2-3 lectures and in my previous exercise which you have done with me in all those lectures. I have told you the ab initio method consists of 4 main steps. The first step is in which we write y is equals to a of x, means we write the function, and then in second step we bring increase in y as well as in x, like this. Now the third step is we subtract both equations. If this is our equation number 1 and this is our equation number 2, when we subtract these two equations, we get del y is equals to a x plus delta x minus a power x. And if I write, like, if we split this term like this, so there is no difference between these two equations. And then the third step is we divide both sides by delta x. So delta y by delta x is equals to a delta x minus 1 divided by delta s. I have taken ax as a common. Now apply the fourth step, the well-known step. These all steps are you are very well familiar with all these steps. We take limit delta x approaches to 0 on both sides. So limit delta x approaches to 0, delta y by delta x is equals to limit delta x approaches to 0, a delta x minus 1 divided by delta x. Now here we use one theorem of limit. Here is a of x is a term in which we don't have any delta x, so we can write it here, and the rest of equation in which we have the variable delta x, we write it with this limit. Now the theorem which we will going to use here, that is limit h approaches to 0, a power h minus 1 divided by h is equals to 1. This is the result which we will use here. This is the result which we will use here, and we can write ax into 1. So f prime of x means first derivative of our function, that is equals to a. This is the not the part of this solution. Here we have used this statement of this theorem. Now this is the first method through which we find the derivative of any um, uh, the general form of this exponential function. The second method, the formula method, through which we find if we have dy by dx of a power x. So when we apply the power over here, first we write this function as it is, and then we apply derivative on its power. So here we have x, and we are calculating the change of x with respect to x. Both variables are same, so derivation of x in this case is equals to 1. So a of x is the answer. So in both cases we have the same result, but it is up to your question that which method is asking through which you can solve your question. So this is the general form of your exponential function. But here we have is the complete solution of uh, general form. Now this is the derivative of natural exponential function. This is the result of our previous deduction. If we take in this this is the derivative of natural exponential function. So in natural exponential function, the result is same. Here we have a is equals to e, means we are going to find no, not like this. We are going to find means here we have exponential is equals to e, means y is equals to e power x. The previous result in our previous result we have written y is equals to a power x. So when we take a is equals to this exponent, which is the natural exponential function, so we can write y is equals to exponential of x. So by doing the same step we can solve this exponential function. We can solve the derivative of this natural exponential function. So this is when you apply the derivative, the formula method, the same result you will obtain. And now you can see the derivative of general logarithmic function. Now general logarithmic function, derivative of general logarithmic function. This is the definition of general logarithmic function. If a is greater than 0 and a is not equals to 1, and the third thing, x is equals to a power y, then the function y is defined as y is equals to log of ax, in which x is greater than 0 is called the logarithmic function. Now your concern is started from here. We have suppose y is equals to log of ax. I will derive this formula for you. Y is equals to uh, first I will write here derivation of logarithmic function in which we have y is equals to log of a x. So this is the the first step in which we write y is equals to this, and step 1. In step 2, y plus delta y is equals to log of a x plus delta x. and this is the step 2. Then step 3. In step 3, what we will do, we subtract these both equation and get log of a x plus delta x minus log of a of this x. Now we simplify this whole terms. Now when we simplify, y delta y is equals to, I will write it again, delta y is equals to log of log of uh, log of a x plus delta x minus log of a of x. Okay, now this is the property of log, that we can write it like x plus delta x divided by x. So whenever we have log of m minus log of n, we can write it log of m divided by n. So by using this property, we can write this like we can write this equation like this. So if we apply log of a x by x plus delta x divided by x, and when we simplify it, we can obtain 1 plus delta x divided by this x. Now the third step, step number 3, in which we divide delta y on both, not delta y, we divide delta x on both sides. So delta y divided by delta x is equals to log of a 1 plus delta x by x whole divided by delta x. Okay, the fourth and last step, step 4, is we apply limit delta x approaches to 0 on both sides. So limit delta x approaches to 0, delta y by delta x is equals to limit delta x approaches to 0 log of a 1 plus delta x by x whole divided by delta x. Okay, if I divide this whole equation, multiply and divided by x by x. Now x by x into limit delta x approaches to 0 log of a 1 plus delta x by x divided by delta x. So actually I am multiplying and divide x by x intentionally, because here we are going to apply one theorem of limit in which there are some deficiency of some terms. So by multiplying and divide this x, we complete our whole statement of theorem. And when we complete the statement of theorem, we can apply the direct result of that theorem, which will be make our calculation easy. Now 1 by x is not required, so we write 1 by x over here, and then limit delta x approaches to 0 x into log of a 1 plus delta x by x, and if I write delta x over here, so it makes no change, so it will there is no change of writing delta x over here. So 1 by x limit delta x approaches to 0 log of a 1 plus delta x by x whole power x by delta x. This is also the property of theorem of log, that if we have if we have if we have m log of x, then we can write it log of x power m. So same thing I have done over here. Now I can apply. Now if we 1 by x, now if we have limit and log at a time, then first we apply the limit. I will write log of a over here, and then limit delta x approaches to 0, 1 plus delta x by x over x by delta x, and this is the complete statement of our theorem, and this is equals to 1 by x log of a into the same calculations. You can see here there is a proper procedure through which they have solved the whole exercise. Now, okay, now we can write here log of e. This whole theorem is equals to this exponent, and we know that these both functions are empty functions of each other, so when they cancel with each other, I have just log of a. So derivation of d by dx of log of ax is equals to this 1 by x. And if you, this is the first principle method, and if you solve this by using the second method, second method, now d by dx of log of ax, by using this method directly you can write it 1 by x. Whatever you have with log, you will write in this reciprocal form, and then apply derivation on this x. So here I have x and x are same, so derivation of this x is 1. So answer is 1 by x. Now here we have one corollary of this actual function, derivative of natural logarithmic function. That was the general logarithmic function which we have done, and now we have the derivative of natural logarithmic function, in which the natural logarithmic function we use this log of x, ln of x. This is the natural logarithmic function, but you can see the calculations are same. The first y is equals to log of x. In second step, delta y and delta x, we have used this increments, and then when we subtract both equations, we get delta y is equals to log of x plus delta x minus x, and again we have applied here the property of log, and then we get log of 1 plus delta x by x. The third step, we have divided both sides, we have divided the both sides by delta x. Then in fourth step we apply the limit, and then we multiply and divide by 1 by x by x, and we use x by x according to the the rules of log, and then we apply the limit before this log, and because we have this full statement of limit, and then we apply this limit rule, this limit theorem, we get 1, and so this is the final result, that d by dx of log of x is equals to 1 by x. So these are the two derivations of two different functions, the exponential function and the logarithmic function. Now come to the exercise. The exercise is at page number 85, not 85. Exercise is at page 89. So please open your books and see page number 89, exercise 2.6, in which the first question is, question number 1 is find the derivative. F prime of x is the first derivative, or you can write it dy by d of dx of this function when f of x is equals to exponential power under root x minus 1. Now here is the complete solution, but even then I will solve it for you. Now you can see I will start it on next page. Exercise 2.6. The first question is find f prime of x, and its first part is f of x is equals to exponential under root x minus 1. So dy differentiate on both sides, and when we apply the derivation dy dx of exponential under root x minus 1. Okay, now these are the two terms, so we apply derivation on both terms separately. Minus, sorry, this is on the power, sorry, this thing is in the power of exponential of x minus 1 is over here. Okay, now we apply directly the exponential function, and we must keep in our mind whenever we apply the derivation on the exponential function, the exponential function will remain same. There is no change in this exponential function. We write this exponential function as it is, and then we find derivative of its power. Whatever you have in power, you will find the derivative of that power. Now, exponential of under root x minus 1, here we have two terms. You can apply derivation separately. So instead of writing under root x, if I write 1 by 2, so it's okay. Then dy dx of this 1 and exponential of under root x minus 1. If you differentiate, you will apply the power rule. You will bring 1 by 2 before this x and then subtract minus 1 from this original power. Then dy dx of 1, you know that 1 is a constant function, so derivation of 1 is 0. Again, now this is the result, and you just write it like 2 into under root x is the answer of your this first part. Now I'm going to solve the third part for you. You can see the second part over here. This is the solution of your second part. F of x is equal to x cube into 1 exponential 1 by x, means these are the product of two functions. You first apply the product rule and then you differentiate both functions separately. Now here you have the third part, in which f of x is equals to, in third part here you have f of x is equals to exponential of x 1 plus log of x. So when you apply the derivative on both sides, dy dx of exponential of x into 1 plus log of x. So here as you see that exponential of x multiplied by 1 plus log of x means first you have to apply the product rule. So dy dx of exponential of x 1 plus log of x will remain same, plus exponential x will remain same, and you apply derivation on 1 plus log of x. Okay, now when you apply the derivation on exponential of x, I have told you the exponential function will remain same, and you differentiate its power, not like this, sorry, you differentiate whatever you have in its power. So here you have x in its power, and as this function will remain same, then exponential of x, here you have two terms 1 and 2. Now you apply derivation separately on both terms, dy dx of 1 plus dy dx of log of x, and then here you have derivation of x with respect to x, so exponential of x into 1 and 1 plus log of x, log of x plus exponential of x, derivation of constant is 0, and exponential of this natural function. So natural function derivative is 1 by x, and then derivation of this x. In this case you have to apply both rules of exponential function, derivation of exponential function, as well as derivation of logarithmic function. X 1 plus log of x plus exponential of x into 1 by x. So this is the result, exponential of x 1 plus log of x plus 1 by x is the answer of your question. So this is the solution of your first part. Okay. Now the fourth part. This is the result of fourth part. F of x is equals to exponential of x divided by exponential of minus x plus 1. This is the solution of your fourth part. In this case, you have to apply the quotient rule. And then according to the formula, you differentiate the different terms. I will solve the sixth part for you. You can see the solutions of all these parts, and now I'm going to solve this. I will solve the sixth part for you. Okay, the sixth part is f of x is equals to exponential of ax divided by exponential of minus x. F of x is equals to exponential of ax minus exponential of minus ax divided by exponential of ax plus exponential of minus ax. So when we apply derivation on both sides, we have, first we apply the quotient rule. So exponential of ax plus exponential of minus ax whole square, and then exponential of ax plus exponential of minus ax will remain same, and we apply derivation on exponential of ax minus exponential of minus ax minus exponential of ax minus exponential of minus minus exponential of okay exponential of ax minus exponential of minus ax will remain same, and you apply derivation on exponential of ax plus exponential of minus ax. So now this is the formula. Now you start derivation. Exponential of ax plus exponential of minus ax into, here we have these two terms. So when we apply derivation separately on both functions, we have exponential of ax is remain same, and then we apply derivation on ax minus exponential of minus ax will be remain same, and then d by dx of minus ax minus exponential of ax minus exponential of minus ax will remain same, and you apply derivation on this part, and then exponential of ax into d by dx of this ax plus exponential of minus ax into d by dx of this minus ax, and whole divided by this exponential ax plus exponential minus ax whole square. Now here we have exponential ax plus exponential minus ax, and in this case this is the for I will give you the example. Then whenever we have d by dx of 2x, 2 is any constant number, so what we do, we bring this 2 before this derivation, because in this case no need to apply derivation on a constant function. 2 is here, and d by dx of this x and means 2 into 1. So same result over here. We have a exponential of ax, then minus plus exponential of a into exponential of minus ax minus exponential of ax minus exponential of minus ax into a into exponential of ax plus minus a into exponential of minus ax and whole divided by exponential of ax plus exponential of minus ax whole square. Now at this stage your derivation is done. Now you just need to simplify all these terms. Now here we have exponential of ax and then okay we just calculate all these terms, and when we simplify all the terms, if I write it e ax plus e minus ax, and if I take a common from here, a is here, and then I write e exponential of ax plus exponential of minus ax minus exponential of ax minus exponential of minus ax. If I take again a as a common over here, then exponential of ax minus exponential of minus ax and whole divided by exponential of ax plus exponential of minus ax whole square. Okay. Now you see that this term and this term are the same terms, and these both terms are the same terms. So we can write in our next step, instead of multiplying these both terms, we can write this term whole square. Like this. I take a as a common from both terms, then exponential of ax plus exponential of minus ax whole square minus exponential of ax minus exponential of minus ax whole square and whole divided by exponential of ax plus exponential of minus ax whole square. And now if I simplify this a into exponential of 2ax plus exponential of minus 2ax plus 2, because the bases are same, so they will cancel with each other, just we have 2, then minus exponential of ax minus exponential minus 2, sorry 2ax and then plus 2 and whole divided by this exponential ax plus exponential minus ax whole square. You cancel some terms. This will be cancelled with all these terms, and just you have 4a divided by exponential ax plus exponential minus ax whole square is the answer of your question. Now this is the solution. Now I will solve the last part of your question number 1. The last part is 8th part in which log of under root exponential 2x plus exponential minus 2x. So let's say y is equals to log of under root exponential 2x plus exponential minus 2x, and we apply the derivation. Then this is the natural log, so 1 by under root exponential 2x plus exponential minus 2x into d by dx of exponential 2x plus exponential minus 2x whole power 1 by 2. Instead of writing this under root, I have written its value. The rest of calculation is very simple. Exponential 2x plus exponential minus 2x. First we solve this power 1 by 2, then exponential 2x plus exponential minus 2x 1 by 2 minus 1, and then derivative of this inner function 2x plus exponential minus 2x without power. Now you can see we first solve this log, means when we have differentiate the log function, we write it 1 by divided by this whole argument, and then derivation of this part of this log function. Now in second step, this function will remain same, and we first solve the power of this factor, and we bring 1 by 2 over here, and then without touching the inner part we subtract minus 1 from the original power of this factor. And when this thing happened, then we go to the inner side of this fraction, this factor, then d by dx of this whole factor without any power. Now the rest of question is very simple. Exponential of 2x plus exponential of minus 2x into 1 divided by 2 into exponential 2x plus exponential minus 2x, and then when you apply derivation on this function, you will get 2 into exponential 2x minus 2 into exponential of 2x. Now the rest of work is simple. You just simplify the equation and you get the answer of this whole question. Now I will move to question number 2. You can see here the solutions of other parts also of question number 1. This is the last part which I have solved for you. So now the question number 2, in which we have to find the dy by dx if we have these different functions. First, second, third, fourth, these are the simple function. In this part I will just solve this eighth part for you. In eighth part we have the okay in eighth part we have the eighth part is y is equals to exponential power minus 2x into sine 2x. Okay. Now first thing which you have observed, that these are the two functions. First function and this is the second function. So first when we apply the derivation dy by, sorry, this is not the dy by dx. We differentiate both sides with respect to x. So dy by dx is equals to d by dx of exponential minus 2x into sine of 2x. So we apply the product rule. Exponential minus 2x will remain same, and d by dx of sine 2x plus exponent d by dx of exponential minus 2x and sine of 2x will remain same. And you know the derivation of these two functions means whenever we have exponential minus 2x, derivative of sine 2x is cos 2x, and then obviously derivative of its angle, plus exponential of 2x minus 2x is minus exponential minus 2x. First we write it as it is and then we differentiate its power, and sine 2x according to the formula remain same. Then exponential minus 2x cos of 2x, and derivative of 2x is 2, and plus exponential minus 2x, and derivative of this function is minus 2 and sine 2x. So derivation is complete. Exponential minus 2x cos of 2x plus minus 2 exponential of minus 2x sine of 2x is the answer of this part. Okay. Now you can see here the first part of question number 2, x square into log of x. You can see it's the product of two functions, x square and log of x. So instead of writing a log of under root x, we can write it 1 by 2, which will make our calculations easy. So now we start differentiation. Dy by dx is equals to 1 by 2 d by dx of x and log of x. So here they have applied the product rule and get the same result. Y is equals to x of log of x, the same calculation, same pattern of calculation is going on. Then in third part, you can see fourth part, fifth part, you can see the solution is very easy. So just quotient rule, product rule they have applied, and I have told you the formulas of exponential function and logarithmic function. By applying these two methods, you can solve all these formulas, all these questions. Now I would like to solve this 10th part for you. Y is equals to x into exponential sine of x. This is the part. Now I will solve it for you. Question number 10 is, it's a very simple question that it's looking difficult. Y is equals to x exponential of sine of x. It's the first function and it's the second function. So dy by dx is equals to d by dx of x, and exponential of sine of x will remain same, plus x will remain same, and we differentiate exponential sine of x. Now the derivation of x is 1, and here we have exponential of sine of x plus x. This is the exponential function, and its power we have sine of x. So first we solve this exponent base, and we know that the exponential function, first we write exponential function is as it is, and then we differentiate its power like this. So exponential of sine of x plus x, exponential of sine of x, and derivative of sine of x is cos of x. So this is the answer of our question. Now these are the solutions of all the questions, and now y is equals to x plus 1 whole power x, and we have taken the log on both sides. I will solve this part for you. Okay. Y is equals to x plus 1 whole power x. If we take log on both sides, so log of y is equals to x log of x plus 1. Now differentiate both sides with respect to x. Now you know that log of y, so the derivation of log function is 1 by y, then dy by dx, and again it's the product of two functions. So first we differentiate this x, log of x plus 1 will remain same, plus x will remain same, and we differentiate log of x plus 1. Now 1 into log of x plus 1 plus x into 1 by x plus 1, then d by dx of this inner function. Now log of x plus 1 plus x divided by x plus 1, and then when we apply the derivation on inner function, we have 1 plus 0. So log of x plus 1 plus x divided by x plus 1. But the one thing here, we have 1 by y dy by dx, and we have to find just dy by dx. So we bring this y over here, log of x plus 1 plus x divided by x plus 1. So what is the value of this y? We just write the value of y and get the result.